All right, 07e, says during the first 6 seconds, how many inches does the particle travel? Is that asking for displacement or distance traveled? Yeah, distance traveled. How many inches total in any direction does it travel? All right, so we'll come up here. It says during the first 6 seconds. So we're not using all of the graph. That's kind of important. So remember, it's the absolute value of the displacements between turning points. So I think we can kind of do that geometrically here. From 2 to 4. Oh, good ears. I didn't even hear that. From 2 to 4, it travels in the negative direction. How far?
12.
Yeah. Oh, yes, that'll work. So the distance, I'm going to do the work here. Yeah, we go from positive 6 down to negative 6. So if you just want to write 12, that's fine. If you want to show negative 6 minus 6, and then take the absolute value of it, that's fine. And then from 4 to 6, we ended up at 0, and we started at negative 6, so minus negative 6. That would be the displacement. Or you could just say I'm moving up 6. Either way, the total distance is what? 18. Yeah, let me take this down below. So a little bit easier with the graph. We don't actually have to plug things in and compute. Now, if I do have that top line there, I'm going to go ahead and put distance as well. I'll keep them both, and so that equals 18 inches, right? Particle's velocity at t equals 5. That's instantaneous or average? Instantaneous. So that's x prime of t, or I'm sorry, 5. We're y prime of 5, right? Thank you. Y prime of 5 or v of 5. But we look up here, and this is the graph of position. So what are we really looking for at 5 to answer the question? The slopes, right? So it's on a little line segment. So you can kind of just calculate it, right? We rise how much from negative 6 to 0? We rise 6, and we run 2. Now, here's kind of a thing that I'll be saying all year long. If you're doing like a free response, if you do some work in the graph, as long as those values in the graph show up in your calculations, you'll get credit for the method, right? So short of showing the difference quotient, if you just have plus 6 and a plus 2 there, that's rise over run. You could come down here and say that that is then 6 over 2. And if those values are in the graph, we know exactly where that comes from. And then, of course, you could stop here, but I'll go ahead and call it 3, and that'll be inches per second. For the previous one? From during the first 6 seconds? From 2 to 4, I'm traveling in the negative direction. Yeah, there you go. You were looking at a different time interval? Okay. Hey, I'll get it this time, eh? All right. What is the particle's velocity at t equals 5.99999? What is the velocity at t equals 5.99999? That's about right there, yeah? Should it be the same as it was at 5? Are we still on the same line segment? We are, yeah. And even though it looks like we're close to t equals 6, we're still miles away. So I'll put y prime of 5. Again, I'm putting y prime of 5 because they gave me the graph of y, so that's kind of using the derivative. Once I defined it above as v of 5, if you want, you could just then say v of 5.99999 also equals 3 inches per second, because we've defined the velocity above as the derivative of y. All right, what would the velocity be at 6 seconds? Velocity is the slope, right? Slope is the derivative. What's the value of the derivative right there at 6? Does not exist, right? It's not differentiable there. Most things in the real world cannot change velocities that rapidly from positive to negative, or even from one positive to a different positive, okay? Because it's not through a continuum. So v of 6 equals dne. Inches per second? Nah, you don't have to put that on dne. Doesn't exist. During what open intervals from 0 to 7, so now we're back to using the entire graph on the open interval, at what time or time intervals is the speed the greatest? The speed the greatest. Well, what are we looking at in terms of speed then on here? Absolute value of the slope, right? So literally the steepest part in any direction. Well, there's really only three candidates, yeah? We know that the slope of this region right here was 6/2. It was 3. What was the slope of this little piece here? We haven't calculated it yet, but it's rise over run. So we rise 3 and run 1, so it's -3. And then this other piece here, this is the only other pitched part, that would have a slope that's negative, so that's going to be 12, or down 12, so -12 over, what, 2? So that comes out to be -6. So we have slopes of -6, 3, and -3. Where is the graph the steepest then? When it's -6, right between 2 and 4, like you said. So speed doesn't care what the sign is. We're looking for the magnitude of the pitch. So it'd be from 2 to 4. So the speed is the greatest. Speed is greatest for, you could say, 2 less than t less than 4 seconds, or you could say on t epsilon 2 to 4, like that. Either way. You could technically say on up above 2 with the inequalities. And then where's the velocity the greatest? Well, now does the sign matter for velocity? Yeah, we want it to either be the biggest positive number, or if all the slopes are negative, we'd want it to be the least negative, yeah? Or there's only one that has a positive slope, right? One interval with a positive slope. So even though that's not the part of the graph that's the steepest, it's where the velocity is greatest. So that's from 4 to 6. 4 to 6. Velocity is greatest from 4 to 6. And again, notice I'm labeling both pieces because we're doing more than one thing in this one part. For 4 less than t less than 6 seconds, putting units there, or on the interval t epsilon, 4 to 6 seconds. There we go. And it did ask for the open interval, so that's why we don't worry about brackets or less than or equal to. Okay? So scalar versus vector. And then what is the particle's acceleration at t equals 3? T equals 3 is going to be right here. So if the slopes are the velocities, what would we be looking for the accelerations? The change in the slopes, right? What do we know about the slope of a line or a line segment? It doesn't change. It's constant. So even though the positions are changing, the velocities are constant. So what should the acceleration be? 0. So you could say, since we labeled v, you could say v prime of 3. And if you want to label that as a, you can. A of 3 equals 0. What if it asked you to justify? Let's add that on there. Or explain why. This one would probably say explain. We would say, since the slopes of y of t are constant at t equals 3 seconds. Something like that. Remember, we don't say the slopes of the graph. Even though there's only one graph given, we don't say slopes of the graph or the function. Always speak very, very specifically. All right, perfect timing. We finished the last of question 7, and we should be able to finish the notes after lunch. So have a great lunch.